All right, let's explore. Number 12, rogue planets. In 2011, a team of astronomers using gravitational microlensing, a technique that detects objects by the way their gravity bends light from background stars, published a finding in the journal Nature that quietly rewrote one of our most basic assumptions about the galaxy. They had found planets, not orbiting stars, but drifting freely through interstellar space, untethered, alone, moving through the dark between stellar systems with no sun to warm them and no system to call home. The assumption had always been that planets form around stars and stay there. Our entire framework for thinking about where planets exist, and by extension where life might exist, was built on that premise. Planets were understood as companions, as secondary objects defined by their relationship to a host star. The idea that billions of them might be wandering the interstellar medium independently had never seriously entered the mainstream. What the microlensing survey revealed was staggering. Jupiter mass rogue planets may outnumber stars in the Milky Way by a ratio of roughly 2 to 1. Then, in 2023, astronomers using the Hubble and James Webb Space Telescopes identified more than 70 rogue planet candidates in the Orion Nebula alone, some of them appearing to travel in pairs, which raised entirely new questions about how they formed. A candidate called CFB-DSIR 2149-0403, detected around 100 light-years from Earth, showed surface temperatures potentially low enough for water cloud formation. Some of these worlds may retain internal heat from radioactive decay in their cores, enough, in theory, to maintain liquid water beneath their frozen surfaces. They travel at tens of kilometers per second through the interstellar medium, silent and lightless, carrying whatever they carry. If there are more rogue planets than stars in the Milky Way, and some of them may harbor subsurface oceans, how many are passing through our cosmic neighborhood right now, completely invisible to every telescope we have ever built? Number 11, the interstellar magnetic field. For most of human history, the space between stars was imagined as a perfect void, an absolute nothing, featureless and inert. That picture began to collapse in the early 1950s when astronomers interpreting polarized radio emissions from across the galaxy were forced to confront an unsettling truth. Threading through every cubic centimeter of interstellar space, invisible and ancient, is a magnetic field whose origin, full structure, and ultimate influence on galactic evolution remain one of astrophysics' most stubbornly unresolved problems. The field is extraordinarily faint. At roughly 1 to 5 microgauss in strength, it is approximately 1 million times weaker than Earth's own magnetic field. By any everyday measure, it is almost nothing. Scientists studying polarized starlight and the behavior of charged particles gradually mapped its presence, tracing it along the spiral arms of the Milky Way, finding it woven into the fabric of the galaxy itself. In August 2012, when Voyager 1 crossed the heliopause and became the first human-made object to enter interstellar space, it directly measured the local interstellar magnetic field at approximately 4.86 microgauss, confirming what had been inferred from a distance for decades. But direct measurement only deepened the puzzle. The field has complex, tangled regions. It does not behave like a simple dipole. It appears to play a role in resisting the gravitational collapse of gas clouds, which means it actively influences where and when new stars are born. High-energy cosmic rays arriving at Earth are deflected and scattered by this field, meaning it shapes what reaches our planet from the broader galaxy. It is one of the primary forces governing star formation across hundreds of thousands of light years. The space between stars is not empty. It is magnetized, structured, and ancient, and we are only beginning to understand what it controls. Number 10. Interstellar dust and the PAH mystery. In 1973, astronomers Fred Gillett, William Forrest, and Kenneth Merrill were analyzing infrared light from across the galaxy when they detected a set of emission features that didn't match any known source. The signals became known as the unidentified infrared bands, and for over a decade, the scientific community had no explanation for what was producing them. The answer, when it came, was stranger than anyone had predicted, and its implications have never been fully resolved. The source turned out to be polycyclic aromatic hydrocarbons, or PAHs, complex carbon ring molecules, drifting through the cold interstellar void in quantities so vast that they are now estimated to contain between 10 and 20% of all the carbon in the Milky Way. These are not exotic compounds. They include naphthalene, pyrene, and coronene, molecules found in coal tar and combustion exhaust on Earth. NASA astrochemist Louis Alamandala and colleagues confirmed their interstellar presence in the 1980s, establishing that the galaxy is threaded with organic chemistry at a scale almost impossible to comprehend. What makes this genuinely unsettling is the biological context. PAHs are precursor molecules to amino acids and nucleotides, the foundational components of proteins and DNA. They have been found inside meteorites that have fallen to Earth, suggesting the interstellar medium is continuously seeding planetary surfaces with the chemical scaffolding of life. Running alongside this mystery are the diffuse interstellar bands, over 500 distinct absorption features detected in starlight since Mary Lee Heeger first noticed them in 1922, with only a handful identified despite a century of investigation. The same organic molecules that form the chemical precursors to life are drifting through the space between every star in the galaxy, and we still cannot fully identify what they are or catalog where they go. Number 9. Stellar streams. When the Milky Way gravitationally captures a smaller galaxy, the process is neither quick nor clean. Over billions of years, the consumed galaxy is stretched, shredded, and dispersed along its orbital path, leaving behind an enormous river of stars that can persist for billions of years as a ghostly fossil record of an ancient act of galactic cannibalism. In 2003, astronomer Stephen Majewski and colleagues published a landmark paper mapping what would become the most famous of these remnants: the Sagittarius Stream, the dismembered body of the Sagittarius dwarf galaxy, wrapped entirely around the Milky Way. The stream contains hundreds of millions of stars spread across a band roughly 50,000 light-years wide. The Sagittarius dwarf has been falling into and through the Milky Way for approximately 6 billion years, and each pass shreds it further. Some of its stars now pass through the solar neighborhood, meaning our galaxy's ancient history of violence has left traces within a few hundred light-years of Earth. The European Space Agency's Gaia satellite, launched in 2013, has since identified over 100 distinct stellar streams in and around the Milky Way. Among them is the Ophiuchus Stream, discovered in 2016, which shows something profoundly strange. It contains inexplicable gaps and density variations that cannot be accounted for by any visible matter in the galaxy. The leading explanation, published by astronomers Adrian Price Whelan and Anna Banaka in 2018, is that dark matter substructures, clumps of invisible mass with no luminous counterpart, have been punching through the stream like bullets, leaving holes that can be detected only by their absence. The space between stars is threaded with the stretched remains of murdered galaxies, and the gaps in those remains may be the only visible evidence that dark matter has a granular, violent structure we cannot directly see. Number 8. Hypervelocity stars. In February 2005, astronomer Warren Brown at the Harvard-Smithsonian Center for Astrophysics detected a star moving at a speed so extreme it had crossed a threshold from which there was no return. Traveling at approximately 709 kilometers per second, well above the Milky Way's escape velocity of roughly 537 kilometers per second, this star, designated HVS-1, was on a permanent one-way journey out of the galaxy. It would never orbit. It would never slow down. It would cross the void between galaxies and drift through intergalactic space for billions of years to come. The mechanism responsible for this was theorized decades earlier. In 1988, astronomer Jack Hills proposed that if a binary star system ventured too close to a supermassive black hole, the tidal forces would be strong enough to rip the pair apart, capturing one star and violently ejecting the other at a fraction of the black hole's gravitational potential energy. The process is called the Hills mechanism, and it turns the black hole at the center of the Milky Way into an occasional star cannon. In 2019, astronomers studying data from the Gaia satellite identified a star now designated S5HVS1, traveling at 1,755 kilometers per second, the fastest star ever recorded, with a trajectory traced directly back to Sagittarius A, the Milky Way's central supermassive black hole. Over 30 hypervelocity stars have now been confirmed, with hundreds more candidates in current survey data. But some of them are anomalous. The star HD 271791, documented by Ulrich Heber and colleagues in 2008, appears to have originated in the quiet outer disk of the galaxy, far from any black hole, ejected by a mechanism that remains genuinely contested. Right now, somewhere beyond the edge of the Milky Way, there are stars that were born in our galaxy, ripped away by forces that shook them to escape velocity, traveling alone through the absolute dark between galaxies. And if any of them had planets, those worlds are going with them. Number 7. The local bubble. Earth does not sit in typical interstellar space. For the last few million years, our solar system has been moving through a vast, irregularly shaped cavity, carved into the surrounding gas and dust of the galaxy, a region of superheated, nearly empty plasma roughly 1,000 light-years across, called the local bubble. We live inside the aftermath of ancient catastrophe, and for most of human history, we had no idea the catastrophe had occurred. The bubble's existence was first suggested through X-ray observations in the 1970s, and more thoroughly mapped by the German-American Rosat satellite during the 1990s. The plasma filling its interior is extraordinarily hot, reaching approximately 1 million Kelvin, far hotter than the surrounding interstellar medium. This heat is a relic. The bubble was almost certainly inflated by a series of 15 to 20 supernovae that detonated beginning roughly 14 million years ago, each explosion driving the shell of the cavity outward, compressing the surrounding gas into dense walls. In January 2022, astronomer Catherine Zucker and colleagues at the Harvard Center for Astrophysics published a paper in Nature demonstrating something remarkable. Virtually every young star-forming region within 500 light-years of Earth, including Taurus, Perseus, Ophiuchus, and the Orion complex, sits on the expanding surface of the local bubble's shell. The supernovae that created our cavity have been actively triggering the birth of new stars along its edges, including, very possibly, the stars of our own solar neighborhood. The bubble continues expanding at approximately 6.7 kilometers per second. Some researchers have proposed, in contested and speculative terms, that the solar system's entry into the bubble around 5 million years ago coincided with changes in cosmic ray flux reaching Earth, which may have played a role in the climate fluctuations of that era. We live inside a scar left by stellar explosions that predated humanity by millions of years. And that scar is still expanding, still shaping the galaxy around us, still creating new stars along its rim. Number 6. Interstellar objects. On October 19, 2017, astronomer Robert Warwick, working with data from the Pan-STARRS telescope at Haleakala Observatory in Hawaii, detected an object moving through the inner solar system on a trajectory that could only mean one thing. It had come from outside. It was not from our sun. It was not from any known comet reservoir or asteroid belt. For the first time in recorded history, an object from interstellar space had been detected passing through our solar system, and it was already leaving. Named Oumuamua, a Hawaiian word meaning messenger from afar, the object immediately defied expectations. Its shape, based on the way its brightness varied as it tumbled, was estimated to be extraordinarily elongated, perhaps as much as 10 times longer than it was wide, unlike any natural object observed in our solar system. Its surface appeared reddish, consistent with irradiation by cosmic rays over an immense journey. It showed no coma, no outgassing, no tail, even as it swept around the sun at close range. Then came the finding that has resisted explanation ever since. In a 2018 paper in Nature, astronomer Marco Micheli and colleagues confirmed that Oumuamua was accelerating beyond what gravity alone could account for. This kind of extra push is typically caused by outgassing, like a natural rocket exhaust from a comet's ices vaporizing in sunlight. But there was no detectable gas, no debris, nothing. Harvard astronomer Avi Loeb and Shmuel Bialy published a paper that same year proposing it could be a light sail of artificial origin. Most scientists favor natural explanations, including hydrogen ice or pressure from solar photons, but no single model satisfactorily accounts for every observed property. The second interstellar object detected, 2I, Borisov, discovered by amateur astronomer Gennady Borisov on August 30, 2019, was entirely ordinary, a normal comet, nothing anomalous at all. Two interstellar objects, and they were completely unlike each other, which means the population of objects drifting through the space between stars may be more diverse and strange than any current model predicts. Number 5. Magnetars. On December 27, 2004, a pulse of energy arrived at Earth from 50,000 light-years away. In approximately 0.2 seconds, a single dead star released more energy than our Sun produces in 250,000 years. The burst was so powerful that it partially ionized Earth's upper atmosphere from the other side of the galaxy, disrupting radio communications and saturating instruments on satellites that were not even pointed in its direction. It came from an object called SGR 1806-20, a magnetar located in the constellation Sagittarius, and it was a relatively small one. Magnetars are a class of neutron star with magnetic fields of staggering intensity, typically between 10 to the 14th and 10 to the 15th Gauss. For comparison, Earth's magnetic field measures roughly 0.5 Gauss. A refrigerator magnet is around 100 Gauss. A magnetar's field at scales of 1 quadrillion Gauss is so extreme that within a distance of approximately 1,000 kilometers, it would disrupt the quantum mechanical structure of atoms themselves, distorting electron orbitals and destroying the chemical bonds that hold matter together in any form we would recognize. The December 2004 event was documented by Palmer, Barthelemy, Gehrels, and colleagues in a 2005 paper in Nature. The energy release, calculated at approximately 2 × 10 to the 46th ergs, remains among the most energetic events ever recorded from a discrete cosmic object. The triggering mechanism was almost certainly a starquake, a fracture in the magnetar's rigid crystalline crust, involving a physical displacement of less than 1 centimeter. Approximately 30 magnetars have been confirmed in the Milky Way as of 2024, cataloged by the McGill Magnetar Catalog, though the estimated total neutron star population of the galaxy runs into the tens of millions. The 2004 flare came from 50,000 light-years away and still disrupted our atmosphere. Calculations have suggested that a comparable event from a magnetar within 10 light-years of Earth, a distance well within our stellar neighborhood, would trigger mass extinction. They drift through the interstellar medium, silent between events, and we cannot predict when the next starquake will come. Number 4. The Cosmic Ray Mystery. In 1912, physicist Victor Hess ascended in a series of balloon flights to altitudes of up to 5 kilometers above the Austrian countryside, measuring ionizing radiation at each level. He expected the readings to decrease with distance from the ground, because the assumption was that natural radioactivity in the soil was the source. Instead, above a certain altitude, the readings increased sharply. Something was coming from above. Hess had discovered cosmic rays, and he won the Nobel Prize in Physics for it in 1936. More than a century later, we still cannot fully explain where the most powerful ones originate. Cosmic rays are not rays at all. They are charged particles, mostly protons and atomic nuclei, accelerated to extraordinary velocities by processes occurring somewhere in the universe. Low-energy cosmic rays are well understood, originating from supernova remnants, their sources established through decades of observation. But ultra-high energy cosmic rays, carrying energies exceeding 10 to the 20th electron volts, represent a different and unresolved problem entirely. On the night of October 15th, 1991, the Fly's Eye detector operated by the University of Utah recorded a single cosmic ray particle carrying an energy of approximately 3.2 times 10 to the 20th electron volts. It became known as the Oh My God particle. That energy, packed into a single subatomic particle, is roughly equivalent to the kinetic energy of a professionally thrown fastball. The particle should not have been able to travel from any great distance without losing energy to interactions with the cosmic microwave background radiation, a theoretical constraint known as the GZK limit, predicted independently in 1966 by Kenneth Greisen and by Georgy Zatsepin and Vadim Kuzmin. Yet it arrived apparently intact from a direction containing no obvious nearby source powerful enough to produce it. The Pierre Auger Observatory in Argentina, operational since 2004, has detected dozens of ultra-high energy events, and the debate over their origin continues without resolution. Roughly one such particle strikes every square kilometer of Earth's surface every century, arriving from the interstellar and intergalactic medium, carrying energies from processes we cannot fully account for, and we have been counting them for over 100 years without a definitive answer. Number 3. The Cosmic Web. In 1986, astronomers Valerie de Lapparent, Margaret Geller, and John Huchra at the Harvard-Smithsonian Center for Astrophysics published a map of the large-scale structure of the universe using the CFA redshift survey, and the image it produced stopped cosmologists in their tracks. Galaxies were not distributed randomly or uniformly through space. They were arranged along vast, interconnected filaments and sheets surrounding enormous empty voids, in a pattern so structured and so intricate that it looked, at scales of hundreds of millions of light years, unmistakably like a biological network. It looked like the inside of a brain. The theoretical prediction had been made in the 1970s by Soviet physicist Yakov Zeldovich, who modeled how small density fluctuations in the early universe would amplify over billions of years into a foam-like cosmic architecture. What no model had fully prepared anyone for was the sheer scale and the strangeness of what that architecture looked like when actually mapped. The filaments of the cosmic web, composed primarily of dark matter and a diffuse superheated gas called the warm-hot intergalactic medium at temperatures between 100,000 and 10 million Kelvin, are estimated to contain roughly 40 to 50% of all ordinary matter in the observable universe. In 2020, a paper by physicist Franco Vazza and neurologist Alberto Filetti, published in Frontiers in Physics, formally quantified what the maps suggested visually. The cosmic web and the human neural network share remarkably similar clustering coefficients and connectivity ratios. The largest known structure in the observable universe, the Hercules Corona Borealis Great Wall, discovered in 2013 by Horvath and colleagues, spans an estimated 6 to 10 billion light-years. The voids between the filaments contain less than 10% of the average matter density of the universe. In those voids, the laws of physics have never been directly tested at the scales and timescales involved. The structure of everything, every galaxy, every star, every atom of ordinary matter in the observable universe is arranged along the skeleton of something we cannot directly see, in patterns that mirror the architecture of thought itself, and the vast dark spaces between those filaments may be regions where our understanding of physical law simply runs out. Number 2, the missing baryons and dark matter filaments. By the late 1990s, cosmologists had built what they believed was a reasonably complete accounting of the universe's ordinary matter, the protons, neutrons, and electrons that make up everything visible, everything measurable, everything that has ever been touched or seen or detected by any instrument. The accounting was deeply wrong. Roughly half of all the ordinary matter predicted by Big Bang nucleosynthesis models was simply missing. Not dark matter, not dark energy, just normal baryonic matter, the same stuff as stars and planets and people, unaccounted for and undetected, and no one could find it. For decades, the missing baryons remained one of astrophysics' most embarrassing open problems. Simulations consistently predicted they should exist, distributed in vast diffuse sheets throughout the cosmic web, but actually detecting gas that thin, spread over distances of hundreds of millions of light years, was beyond the capability of available instruments. In 2018, a team led by Fabrizio Nicastro and published in Nature provided the first strong observational evidence that the missing baryons reside in the warm-hot intergalactic medium threading the filaments of the cosmic web. The definitive confirmation came in 2020, when Jean-Pierre Macquart and colleagues demonstrated through the dispersion measure of fast radio bursts passing through intergalactic space that this diffuse gas accounts for the missing matter. Half of all ordinary matter in the universe had been hiding in the largest structures in existence, too diffuse and too spread out to see for the entire history of observational astronomy. The dark matter filaments providing the gravitational scaffolding for this gas outweigh all visible matter by a factor of approximately 5 to 1. They have never been directly imaged. Their internal structure, their behavior at small scales, whether they are smooth or clumpy, whether they contain substructure that would collide with and disrupt stellar streams, remains essentially unknown. We spent 50 years unable to account for half of all normal matter in the universe. And what that experience tells us is that the full inventory of what exists in the space between stars and galaxies is not yet closed. And the part we cannot see outweighs the part we can by an enormous and humbling margin. Number 1. The interstellar medium as the origin and grave of everything. In 1957, physicists Margaret and Geoffrey Burbage, William Fowler, and Fred Hoyle published a paper now known simply as B2FH, which established one of the most profound facts in the history of science. Every element heavier than hydrogen and helium in the observable universe was forged inside a star. Carbon, oxygen, iron, calcium, the phosphorus in DNA, the iron in blood, the oxygen in every breath, all of it was synthesized in stellar interiors and distributed into the interstellar medium when those stars died. Through stellar winds, through nova events, through the catastrophic violence of supernova. The atoms of which you are made were inside different stars before they were inside you. The interstellar medium is not a backdrop. It is the source material for everything that has ever existed in a form more organized than diffuse gas. The Sun loses approximately 1.5 million tons of mass per second through the solar wind, continuously returning matter to the interstellar medium. Over its 10 billion year lifetime, it will return roughly 45% of its total mass to the space between stars. Every star does this. Every stellar death enriches the medium, raises its metallicity, makes the next generation of stars and planets slightly more chemically complex than the last. But the interstellar medium is also the destination. The timeline laid out by cosmologists Fred Adams and Gregory Laughlin models the long-term future of the universe in phases. The stelliferous era, the period of active star formation, ends in approximately 10 to the 14th years. After the last stars die, their remnants drift through an increasingly cold and dark intergalactic medium for timescales of 10 to the 19 to 10 to the 20 years before orbital decay and gravitational interactions disperse them. Black holes evaporate through Hawking radiation. Stellar mass black holes over timescales of roughly 10 to the 67th years. Supermassive ones over 10 to the 99th years, releasing their stored mass and energy back into an ever-diluting void. Grand unified theories predict that even protons may eventually decay, over timescales of approximately 10 to the 34th years, dissolving the last atomic nuclei into radiation. If that prediction is correct, the matter now locked in planets, in moons, in the frozen corpses of dead stars, will eventually cease to exist as matter at all. returning as diffuse energy to a universe that has grown incomprehensibly cold and empty. The interstellar medium is the beginning and the ending of everything. Every atom in your body was forged in a stellar furnace, scattered into the void by that star's death, and assembled into you by a chain of events requiring billions of years and a set of conditions so specific that the probability approaches zero. When you are gone, those atoms will return to the interstellar medium, drifting, cooling, waiting in the dark between stars for another collapse, another ignition, another brief and improbable interval of complexity, before the long unwinding continues. The space between the stars is not empty, and it is not merely the distance between things. It is the substance from which everything is made and to which everything returns, patient beyond any measure of time we can hold in our minds, indifferent to the extraordinary accident of our having been here at all. If you want to see more videos like this, click the video on screen now and make sure to subscribe.